Well, hello everyone.
Hi
I'm Mads
there.
Torgerson. I'm
Thanks,
one of
Dan.
those C# designers. And
Thank you.
I'm Dustin Campbell. I'm also one of those C# designers. This is what we do.
so as the introduction said, we're going to show you, we're not going to show you all the C# 12 features. There's quite a few. But we will start out by kind of showing you around to where you can find out more, and then we'll focus in on some of the most impactful that are probably going to change how people write code in the world ever after in C#.
Yeah. Okay. So, we also want to talk about a little bit about how you can engage with us. There are a couple of links out there that are useful, but I would recommend taking a look at the Learn site for C# and how to get started, what's new in C#. There's a big document there that explains a lot of things. Also, taking a look even at the Roslyn project on GitHub if you want to engage even more deeply. Getting there's a language features status page that kind of shows the nitty-gritty of where we're going and what we're even looking at next, what's in C# 12 and what's in C# V next potentially. And then finally there's the C# Lang on GitHub where you can engage with us depending on how, again, you can go deeper and deeper and deeper. I just want to hear about C# or I want to engage.
Yeah, that's the last one is the repo where we do all our language design work.
Yeah.
So we have a lot of community engagement, both in the language design and actually in the implementation. And one of the features we're going to show today actually had a lot of input from community all the way up through big parts of the implementation.
Yeah.
So thank you for that.
And you can see here we have a very low kind of text slide here because we're just going to stay in Visual Studio. This is how we like to do things. So let me get that back to 100%. We'll get up to our demo, and we want to show you guys, really what there is to see in C# 12. It's an exciting, honestly, it's a very exciting version of the language.
Yeah, and let's start with something really small, just to get us warmed up, honestly,
like
in here,
an appetizer,
and also maybe
right?
an appetizer,
Yeah.
amuse-bouche.
Oh, ooh, very nice. That's very fancy.
Yeah.
All right.
So let's have fun with that first line of code right there.
Okay, so this has been there since C# 1.0, right? It's a using type alias, right? Where we've created another name to stand in as an alias for a fully qualified type, right? And we've always had to put that fully qualified type there, even though there happens to be a keyword in the language that stands in already aliases system.decimal. Yeah. But we can't type it there. We couldn't type it there in C# 11 for 11 versions of the language.
Yeah. Yeah, we just never got around to dealing with it.
So now
you can just
you are so welcome.
Yeah.
You can just say that. And that's pretty much what we've got to show today.
Thank you. Goodbye.
Yeah.
No, you can put any type syntax there now.
Yeah.
Since it's a using, if you want to put a name type, you still have to put the whole qualified thing. But for any other type syntax, you can just go ahead.
Yeah, and so like, for example, one of the things that you could always put in here if you knew all the secret way of doing things, you could put a value tuple in there. You could make an alias for a tuple, but you couldn't type the regular tuple syntax. But now we can do that, and that's fantastic. This is one I'm really pleased with because even though you could always do that with value tuple, you could never put names in there.
You couldn't get the tuple names.
Yeah, it's like
the
you couldn't put
tuple names.
Because those are like encoded in special attributes. But now, sure enough, we can do that, and that works great.
Yeah.
So.
And of course, there's that oldest of type expressions, pointers.
Pointer types.
How about pointer types?
Yeah. So I can put this back to decimal, and yes, I can put a pointer type there and get an error.
Yes, great. I think I could do that before as well.
The error, though, tells us that, they can only be used in unsafe context. So for this feature, if you are trying to alias things that are pointer types, you can type the unsafe keyword. We kept that as an important part of C# is that when you're doing unsafe things like that, we would prefer that you declare that you're doing so.
All right. So with that, we should probably unpointer it. But
unpointer it.
We got back to decimal there, and now let's go and look at some of the more substantial features.
Yeah, this is I think the first feature we want to look at. We have we've got a record here, which this came back in what, C#9, I think we did records. It's been
Yeah.
a while. And
Yeah.
these have, we had two flavors of records, right? What we called nominal records and positional records. Positional records declare a cool constructor up here, and this constructor, in its parameter list, those parameters become properties, right? It's for declaring properties. And in fact, if I dot into this, you can see those properties are all there, right? That's how records work.
We call that a primary constructor even in records. But for records, it was easy to say what to do with those because records are very opinionated. They're about expressing values. So it was obvious that they should always just get a public property by default representing those. And we always kind of wanted to do primary constructors for all classes and structs, but it was actually a bit harder for the non-record ones because we had to figure out, well, in a non-record type, it shouldn't be opinionated, right? It shouldn't say, oh, these always turn into this kind of member or something like that. And so we finally went ahead and decided what to do with primary constructors when you're not looking at a record class or a record struct, but just a regular class of struct.
And we decided that you could now, essentially that you could now delete that keyword.
Yes.
Yeah.
But now you get an error.
Now you get an error. And the reason we get that error is just to prove that, there is no longer a name property that's declared, right? So if I dot into this again to bring up the completion list, see that there's just the one property, just GPA, which is actually declared as a property.
The one we explicitly declared. And this goes to show that in structs and classes in general, you want to decide how and whether to expose any given piece of data, any given piece of object state, right?
Yeah.
There's not a sort of pre-specified way of doing it. It's up to you.
Yeah, yeah.
So, yeah.
And so this becomes then, these have warnings because they're now parameters, right? They're not properties anymore. And when you have parameters on a method that you're not using, we'll
you just get an unused warning on it.
An unused error, an unused warning, right? And so we can go in, though right now we'll just go ahead and rename these to make them at least look like parameters to us, so that that'll help us.
Since they're no longer doubling as members, public members as well, we can use like the proper parameter naming there, which feels a little good.
Cool.
All right. Well, I guess the first question that comes to mind is like, okay, so I can get constructor parameters on a class. Well, how do I pass constructor arguments on to like my base?
Oh, sure. So if I want to then take these and move them down below, it's very similar to how we do it we allow it with records. If you're familiar with primary constructors on records, it's very similar. You can declare a base type, and then when you declare that base type, you now have a place where you can put an argument list to pass on.
Excellent.
Down. So I can just pass name down here.
Yeah, that works.
And now name's used. Great.
Excellent.
One down.
One down. We should. So I think in this class we should expose name and we should expose ID as public properties.
Sure.
But grades, I think it's fine that we keep that secret and we just have like GPA is using.
Feels better. Yeah, it feels better to keep grades secret.
Yeah.
Okay. Yeah. And certainly not leave it as an array as well, because you can come in and change them very easily. So, okay, we can declare a new property for name to expose that, and we'll make that, I don't know.
Just an auto property.
Yeah, just an auto property. We can initialize it, though, with that parameter that's coming in.
Yes, because the constructor parameter is in scope throughout the whole class, so of course it can be used in initialization.
Absolutely.
Just a member initializer.
It's like your entire class has become this constructor body in a way, right? At least for initialization. And down here, I could also do you ask for two, and let's do this one read only. Right? So we'll do it with an expression body, and then I can also return that.
Right, and that's excellent, but that's kind of different, right?
It is different. That's not initialization.
Right, because this is a body that gets evaluated every time around. Every time you call ID after initialization is already finished. So given that ID is a constructor parameter, like how does it even know what ID is after the constructor is done running?
Right. If I hover over it, it shows me that it's a parameter.
It is a parameter.
So what do we do here?
Well, this is like if you know from lambdas, we have this thing called capture, where if you have a lambda inside of a method, even if that lambda is kept around and run after the method is done, those parameters mentioned in the lambda are still around somehow. We capture them. We find a place to stash them so that they continue to live for everything that is referencing them. And in the case of of primary constructors, the place to stash them is really in the object that we are creating. Right?
Right.
They're secretly part of the object state.
I see. Okay. So this is now stateful, and that by using it in this way, it needs to be stashed so that we can get back later whenever ID happens to be called.
So the compiler sees, hey, this is used after constructor. Let me stash it. It doesn't stash name here because it's only used for initialization, but it stashes the ID. But it doesn't just make a field, a private field called ID. Like you couldn't say this.id.
Right. Okay. So I couldn't do this. I just want to see if that's true. Yeah. No. I definitely can't do that. I only get the property name.
Yes. Yeah. So it's more like an implementation detail. Under the hood, the compiler generates some field that you can't get at directly, but it backs up the parameter. Right.
But suppose I did want a field, right? Or if this capture stuff seems kind of super magic. Is there a way to?
Yeah. I mean, okay. So it does something, right? And since it's parameters, and parameters weirdly in C# are actually mutable. Sorry, that's always been the case.
Yep.
So when you capture a parameter, it is mutable. We could assign to the I don't think we should, but we could assign to ID later. A lot of people like to explicitly make their object state read-only, for instance.
I could assign to it right here.
Yeah. But let's not.
Let's not do that.
And so we should not. We kind of make a default decision here.
Yeah.
Right? But if you want your state to be read-only, for instance, we did discuss should we have a modifier in the parameter list
so I could come up here and say this is going to be read-only. We didn't do that yet.
No,
we're still talking.
We're thinking about it because we kind of want to wait and see. But if you want that, you don't have to use capture, right? You can define your own private field.
So I could declare ID here.
Yes.
And I could assign it with the ID parameter.
Yeah.
And now I've got a field that is. This is now binding to that field instead of to the parameter. And so then throughout the class, except in places of initialization, I'm now referencing the field. And I could come in here and type this dot.
Yes, you could indeed. So we did a little bit of trickery with the lookup rules so that if there's a field, if there's a member, it wins everywhere except in initialization, and the parameter wins there. So that this all kind of does the right thing. And now we can make it read-only.
Now we can make it read-only. That's excellent.
Yeah, and I think it's important to point out that capture is nice, but it isn't like the main benefit of primary constructors. That really is, getting those parameters just into scope for easy initialization. You can lose a bunch of boilerplate. And so some people will make use of the capture, and some people will always explicitly declare their field so that they have more control.
Yeah, I've found myself going back and forth for very small types where it's just like, I don't need these fields, and I'm just using them almost very briefly. The parameters.
Yeah.
I'll leave the fields off, but then in more significant types, I find myself saying, no, I need to see all my state together, and so I put all the fields at the top for that sort of type. I find myself kind of going back and forth depending on the situation.
Right.
Yeah.
And I think we should say that there's there's a new kind of error mode or bug mode that people can fall into with capture that we should probably talk about a little.
Oh, sure. For example, right now we're assigning name to a property. So it's not really exactly capturing things, right? Because we're putting it in our own state.
We're doing our own property. Yes.
Yep. Just like we did down here with ID, but that happened to be a field. This time we were doing it with an auto property. But if I want to say use name somewhere else where I wasn't putting it in state, then down here maybe I want to say name.length. Well, actually, that's kind of weird.
It auto-completed your name.
I tried to type name, the parameter, but it's not there in IntelliSense. And is that a bug?
Well, let's try to force it.
Let's force it, yeah. Okay, so I got length there, and that was fine. But now we see actually that there's warnings elsewhere in my code.
Yeah.
Over on these other uses of name where it's just used in initialization or passed down to the base type. And this is something that can happen. And one of the reasons why IntelliSense was trying to stop us from doing that was this is a case where we're double capturing.
Yeah.
Yeah. The compiler's automatic capturing is happening because we're using it here. And so the compiler says, well, I need to stuff this in a field. But then, and since we didn't reference the property, our own state, but we also put it in another auto property, so we're kind of storing it twice, which is probably not what you intend.
Yeah. So that is, so we figured it's better to give you a warning there, capture that, or catch that. And then if you really, really meant to copy name and to have name be in two different things, one of which is auto captured, well, you can go and make you can go and make your own field instead.
You can still make a field, right? And that will do exactly the same thing. So now this actually references the field, and we're able to get out of that. We're not get out of the double capture situation, but being more intentional and showing in our code more intentionally what we're trying to do.
Now you're doing it. We're not doing it with our auto capture. You're doing it yourself. You're asking for it. You get whatever you get.
Yeah, exactly. So yeah, that's actually a super kind of tricky thing, right? The capture can be kind of tricky.
So this helps it not be tricky for the user. But
one thing I wanted to ask about though is we're doing this. It's very natural, but I'm also not doing anything like what if I want to check grades for some argument validation or something like that. It seems to me like, and this is something we talk about a lot in the C# language design, is the ergonomics of code, transforming code. What is the cliff like we talk about? Like, so if I wanted to say, add some significant complex logic to the constructor, I need now to get to a regular constructor.
Yes.
The old style not old style, just a regular constructor.
The primary constructors don't currently have a way to give it a body, right? You can just do the trivial things that you're doing in initializers.
Yeah, in a field initializer,
But I'm sure you can do ugly things with that would do your validation. But
I can put it all in a lambda and invoke it right now.
Sure. So it's not going to be pretty though. And so we may fix that in a later version of C#. We are talking about should there be a way to do that validation in an object like that. But until then.
Yeah, until then. So as we've been working on the tooling for this feature, and you saw what we did with the completion list, where we're hiding things that might cause double capture, and we're instead we want to provide the tools so that you can easily go into a regular constructor or even come back out. So if I put my caret up here, I bring up the light bulb list here. There is a convert to regular constructor, and that will do exactly everything. In fact, also declaring a new field for grades, assigning everything, using this dot correctly because of how we've chosen to name our fields here, and now we have a regular constructor, and I can just go do what I intended to do. Now this feature, this particular refactoring, we're going to show a couple of others in a moment, is only right now in VS Preview. So we just put out the 17.9, first preview of 17.9. That's available out there today in the VS Preview channel. So this is available there. It's also available already in DevKit, in C# DevKit. So it's a cool feature and it's super useful. It just didn't get it quite in time for the 17.8 release.
And then on the other, so if you want to get out of the primary constructor, this is super easy. If you already have code though that is amenable to primary constructors, there's a refactoring the other way, saying, "Hey, old code, why don't you get spiffed out?"
In fact, it's even if you look carefully, it's even added a little smudge there, saying that you could use a primary constructor, and it kind of sorts that out. If you're doing complex logic here, it won't let you do that. If you're doing logic that could be in a field initializer, it might try and transform that in that way. It's very useful.
Yeah.
But if I bring this up again, it gives me two options. One is just use a primary constructor. And in this case, it is keeping the fields and assigning them, in their field initializers.
So it's avoiding capture.
It's avoiding capture. This is one style. But then there's a style to say, oh, you know what? Do that and remove fields. I'm going for full brevity. And that's exactly what this is going to do. And this gets us pretty much back to where we started, except with this name.length here.
Yeah, we got to get back to
just put that right back.
Code that does something vaguely meaningful, at least.
Yeah, there we go.
Oh, so very nice. So I think we got a good look at primary constructors. We could say a quick thing about chaining.
Yeah, constructor chaining. It's kind of a complicated thing in C#, at least when you first encounter it. It's been there since C# 1.0, but the idea that you can chain constructors together to either a constructor on the base type or constructors in the same type. And we can do that as well here. In fact, we are right here where we call this, but there's some differences with I think, with primary constructors. So if I want to declare a constructor, it takes a single parameter. Well, that's just going to give me an error.
Yeah.
Because in a primary constructor, it must, in fact, have an initializer. So I'm going to go ahead and, well, we know there's a person down below, and I can call that. But now we're just moving the error around. And the reason for this is because with a primary constructor, where we're giving you the ability to use these parameters, auto-capturing them, use them in initialization, we need to guarantee that they have values.
That you actually pass value.
That you actually called that thing.
Pass arguments to them. Yeah.
So with a primary constructor, you must always, in your chaining, go back to that one primary, that constructor at the very top, which is, honestly, is a best practice and been known as a best practice anyways with constructor chaining, though you could kind of make a mess of things and have weird state and all that. With primary constructors, it is now kind of really enforcing that best practice.
Yeah, and of course you don't have to go directly back, as long as you call this.
Yeah.
Because constructors can't be cyclic, they will eventually end up calling the primary constructor, as they do here in the chain.
And that, exactly. That we're not actually calling the primary constructor here, we're calling another constructor that does call the primary constructor. Yeah.
All right.
So, cool. That's primary constructors. That should change the landscape of C# as far as what code looks like. Yeah.
Code will be more terse.
Yeah.
But speaking of that, let's look at, let's change gears here and talk about collections.
Okay.
So we do have a collection parameter to our primary constructor here, the grades one. And it takes an array, and so in all the places where we are passing an argument to that, we are newing up arrays in various ways. So getting hold of
we do it right up here, right? We do it here, or we pass down here, we pass array.empty.
Yeah, I mean, Stephen Tobe told us and put in a little analyzer somewhere that you shouldn't new up empty arrays because they can't be mutated anyway. You should reuse array.empty.
Yeah, use array.empty.
So we happen to know that. So we know it's efficient. Doesn't look super cool, but okay, we'll take it.
It has another cost too, right? Which is that, okay, when I decide that this isn't the appropriate collection type.
Yeah.
Right. I don't want to use an array. I want to use something else that's a little bit, has some different qualities to it.
Let's try that.
Yeah. And so, like, maybe I want to use a list. Maybe I want to pass in list, for example. And if I do that, I can do it here. But now my call sites all need to be updated.
Yeah, because they're syntactically specific to arrays.
Yeah. So we can be clever. Like, we can fix this one and be clever. Like, and say, instead of brackets, I could do parentheses. Ooh. Yeah, which uses the target type new feature, so it's newing up a new list, and then a good old C# 3.0 collection initializer at the end to put the values in. And we can kind of do the same thing down here, right? Except that doesn't work.
Right, because an empty list can in fact be mutated. So
and so there's no such thing as list.empty.
We just have to new one up.
Yeah, but we can be nice and terse with our target type new. And now we've updated the call sites. Of course, in a real app, this is probably
that's a million
absurdly large number of these call sites to fix. But yeah, so now I can do that. But that's painful, and it's also weird passing in a new list every time and all that kind of thing. But it was kind of weird. But that's all right.
It's all right. But actually, I want to use an immutable list instead.
Oh, immutable list. That's the new hotness, right?
It is the new hotness. So better.
And I can do that. And now it's like I don't even have a constructor that takes 0 arguments that I could use a collection initializer with. So we're in bad shape.
Yeah, and I can't use a collection initializer, period, because it mutates. The whole point of a collection initializer is mutate the collection after it's created.
Yeah.
Well, guess what? Immutable lists really are resistant to being mutated somehow.
Right. Instead of mutating the list, it returns you a new immutable list. But collection initializers coming from C# 3, they don't actually know about that. So they just throw that result away.
Right. So what we need, really, it seems, is we need a unified syntax for creating collections.
Yeah.
And we need it to work for many more collections.
Yes.
Okay. Well.
So we did that.
We did that.
Yeah. Okay.
Okay.
We did that, and so we can do that right here. I can put in just square brackets.
Square brackets around the elements. Look at that.
Look at that. And now that passes right in.
Yeah.
Down here, I want to pass in something that is kind of similar to above. There's a code fix for this because this is an error, but it's an error. But it also has a little helper on the bottom that says, this collection initialization can be simplified.
Yeah.
And so we'll go ahead and simplify it.
And
that introduces little square brackets.
Empty.
I hear those showed up in a demo earlier. So yeah, these are the little square brackets, which means the empty collection, right?
Yeah. It's just a collection expression that happens to have no elements in it.
Yes.
So that's really cool, Dustin. So what does it do? What's the point? Like, how does it? These are. I mean, the reason why this was all weird is that these different collection types are created in different ways.
Yes, like if I, you know, and a good example might be like something like another list, right? Immutable array, and by having this ubiquitous kind of syntax, we can switch that over to immutable array right away and get the benefits of it. What do? They do an amazing amount of things, right? To sort out, like, okay, well, how do I create this? How do I add elements into it? And trying to be ubiquitous. I like that word of just kind of being general. Like it's a general mechanism for really any collection or potentially any collection. But also we want it to be as efficient as possible. All of these collections have different characteristics, and with immutable array, for example, there are very specialized ways of working with that that we want to be as efficient as possible. So. So this is where we kind of get into some of the other bits about this, right? Where we want to show how can I say immutable array is something we can create as a language.
For my collection, like this will try to fall back to like collection initializer style stuff. If there's nothing else to do on the type.
If it's got the add methods and all that, we'll try and do that.
But that's sort of a last resort because it's inefficient and it often doesn't work.
But that wouldn't have worked with immutable array.
It wouldn't. But any collection gets to say how to create me with a collection expression.
Yes.
And let's go look at how you do that. Because immutable array is one of those that does that.
Yeah, so I'm going to press F12 and wait for navigate to, there we go. So, and in here, looking at immutable array, we're going to find that this version of it has a special attribute called collection builder, which says, okay, this is, you know, that it's essentially what it's going to do is it's going to look for a particular method on a particular type. And it's going to go back to the immutable array type, that's the non-generic one.
And call the create method.
And call the create method. So let's go to that, and let's look. And there's a whole bunch of create methods here. But the one that collection's going to use is that one. That's the one that we're going to try and use. We want to pass in a read-only span of items. We want to, and so that if we can construct that set of items as efficiently as possible, we want to pass them efficiently as well, be able to process them efficiently.
And by using a read-only span overload, there's a high chance we can pass all kinds of things that aren't allocated. So, so the compiler has a good shot at not allocating anything, and that's why we'll typically go for that one.
Yeah, and so that's kind of the magic, and this is something that you can add to your own types in order to make them kind of collection expression enabled. So if you're a library author, this is a great attribute to, you know, if you're a library author dabbling in collections, in custom collections, this is a good thing to take a look at.
Right. Okay, but if we go back to our code, so what we just showed is the case for immutable array and actually also for immutable list. But if you go to list itself.
List itself. And list itself, which we were showing earlier, this also works, but this is different. If I were to go to that list type, it would not have a collection builder attribute. And the reason is that we've decided that there are some types that are just so core to .NET. You know, system collections immutable hasn't been available across all variances of .NET since .NET 2.0, Framework 2.0, right? Like list has. So it needs a way to extend itself into this language feature, right, to make itself available. But list, we know about it. It's well known, and so we just know how to operate on it.
The compiler simply has a list of types that are well known to it, and where the implementations are well known as well. So it will just do whatever it takes and assume that those are indeed the implementations. And if you provide your own, well, you probably shouldn't have.
Yeah. You know, so we've got types that can be, you know, provide an attribute that allows them to be used by collection expressions or targeted by collection expressions. We have types that the compiler already knows about, but that are concrete at least. But what about like interfaces?
Sure. Yeah, we should.
There are lots of collections that are just interfaces.
We should mention that to that bucket of well-known types, we also have arrays.
Yeah, arrays as well.
So it will handle arrays really beautifully.
It will have no span, read-only span
as well. Yeah, those are just known by the compiler.
Yeah.
But yeah, it's what if you had
typical with this is like to pass in like IEnumerable, right? How does that work?
It works.
It does work.
It works by not putting red squiggles. That's how it works.
We put red squiggles down below because it's not sliceable, but that's another problem.
Okay, yeah.
It's a different feature.
We should look at that at some
point.
We
should.
The thing is, you don't, I mean, even if you use the attribute trick that we showed before, that you can put that attribute on an interface as well. And then that interface will tell you how to create a concrete instance of some derived class, some class that implements the interface. But similarly for the well-known interfaces, like essentially think of all the generic interfaces that array implements.
iList of T, iCollection of T, iRead-only list of T, iRead-only collection of T. Like there's all these things.
And iNumerable of T. I think it's those five.
I think it's those five. Yeah.
For those, we will be very opinionated in what the compiler does in a sense and just go for the most efficient thing that we can.
Right. And so in the case of iEnumerable, what is very interesting about this is that we could choose something that's well known, right? Like list. But in that case, it comes with another set of baggage, which is that we want to make this true, the collection type that we choose, that we create. We want it to make it true to the interface that's being passed in. So if it's something that's kind of read-only, like iEnumerable, we don't want to like say, well, the compiler's just going to put a list in there.
And then you can cast back out to list and abuse its read-only.
And abuse its read-onliness.
So we guarantee for those interfaces that don't have mutating members on them that we will not make them mutable even through casting.
Right. And so this is kind of a third set of way of how we select what type is going to be created. In this case, we generate one.
Yes.
For your code, right? So that that is read-only at its core, is efficient, and so for the read-only things, that's what we'll do, so that you can't cast those out and mutate them.
And I think it's really important to highlight that when we talk about making it efficient, like we have a goal for this feature that not only is it as beautiful, more beautiful than anything you could have written before, but it's also as efficient or more. Right?
Yeah.
So because you can do a lot of tricks. When you have, when you know the length, when you have some constant members, we can do stack allocation, all kinds of things. Whenever we know enough about what's coming in and what it's going into, and we will feel free to do all those things. Some of which you might have known to do, but they would have been too ugly to put in code that you have to maintain, right? Because we do it behind the scenes, we can go all the way. Right. And we can keep, as we keep getting more and more tools, even behind the scenes, to give better performance to this, we can actually change what we generate for any given piece of code to something that's more efficient.
Absolutely. One other thing I also want to mention here, beyond the performance, I want to talk about the fact that we can also put together collections, making collection expressions even more powerful.
Yes.
It's what we call spreads, right? So right here we have this collection expression that takes 3 elements, and they're literals, right? But maybe I've got a collection I want to bring in. Maybe your grade point average doesn't appear to be all that stellar. Here, I'm sorry, even though you made it much further in school than I did, but I could maybe go find some grades.
Trying to bring it up.
Yeah, bring some grades from somewhere else, perhaps, and I could use this dot operator, which in this context is a spread operator, to bring this collection in here, and it will create my collection expression, also including those elements all flattened out.
Yeah. That's excellent. And you can actually. You can put those you can have multiple spreads in the same collection expression. You can put them wherever you want.
They don't have to be the same type. In fact, I believe this is of type read-only span itself, right? So very, very different. And that's a very powerful aspect of this feature as well. And again, we will try and do it as efficiently as possible. How we're going to add those elements in, we're going to do it as efficiently as we possibly can.
Yeah, so, perhaps there's a way, perhaps we can know cheaply how big it is, and then we can pre-allocate space for it. And if we don't know, well, then we'll have to fall back to something more expensive. But we can make those trade-offs.
Absolutely. Now, one thing I wanted to ask about, do you want to talk about how they kind of relate to list patterns? Because we have this cool list pattern down here that has a lot of really similar syntax. We've talked about the empty square brackets. We've talked about the spread. And we've got errors down here because, unfortunately, iEnumerable is really hard to, it's not really a list.
It doesn't fit into the list pattern today. We might do that in the future.
But I can put it back to something that
put it back to...
Put it like a mutable array.
Yeah.
Right?
Well, when we did patterns, when we had a pattern that sort of corresponded to a specific kind of object, we always try to make the pattern syntax correspond to the creation syntax of those things. In this case, we had the list patterns first, and so we did the opposite of making the creation syntax for collections match the syntax of the patterns that deconstruct or match on collections.
Yeah, I just made sure we had all this on screen at once, because you can see here we have, this is a collection expression that produces an empty collection. But here is a list pattern that matches that empty collection, right? But likewise, this spread up here matches this slice down here, which says, give me all the rest of the things in a list pattern. It's very cool.
So we are elegant.
Yeah.